We have an example problem here. Air breaks down when the electric field strength reaches 3 times 10 to the 6th newtons per coulomb, causing a spark. A parallel plate capacitor is made from 2 4-centimeter diameter discs. How many electrons must be transferred from one disc to the other to create a spark between the discs? Okay, so parallel plate capacitor, that's a key word. If you remember, a capacitor has 2 plates that are parallel to each other, and they have equal and opposite surface charge densities. First one doesn't want to write. There we go. So this would be a side view. So I'm not seeing the actual discs. So we would have 2 discs that are facing each other. One of them is positively charged, one is negatively charged. And the electric field between them would point from the positively charged disc to the negatively charged disc. Okay, again, what makes it a capacitor is these equal and opposite surface charge densities. We have our equation for E of a capacitor is eta over epsilon naught. Let me draw that a little better. Eta meaning the surface charge density. Eta is the amount of charge on either plate divided by the area of the plate. Okay, so here, electric field strength of 3 times 10 to the 6th newtons per coulomb is what causes this spark. We're trying to find out how many electrons would need to be transferred from one disk to the other to create this spark. So as far as our equation is concerned, we can solve for the charge that needs to be on the plate. So the number of electrons more on the negative plate that need to be there in order to have this electric field. This Q is not the number of electrons, it's the amount of coulombs. So the capacitor electric field is 3 times 10 to the 6th. Epsilon naught is a constant, which is 8.85 times 10 to the negative 12. The units are coulomb squared over Newton meter squared. And then we need to multiply by area, and that's the area of the plate. Both plates have the same charge and the same area. And so this is the area of either plate. It's a circle because they've given us a diameter. So area is pi r squared. Since the diameter is 4 centimeters, the radius, of course, will be 2 centimeters, which we want in meters. Because in terms of our units, the newtons here are going to cancel. The meters, once we square them, will cancel. This coulomb will cancel with one of those, which in turn gives us coulombs, which is what we need if we're solving for charge. So plugging the numbers in. I'm getting 3.336 times 10 to the negative 8 coulombs. The question, though, is how many electrons? So essentially, to have this negatively charged plate have a negative charge of 3.336 times 10 to the negative 8th coulombs, how many electrons would need to be there? We know 1 electron is 1.6 times 10 to the negative 19 coulombs. That's our fundamental unit of charge. So our number of electrons, we just need to take this number of coulombs we've solved for and divide by the fundamental unit of charge. And we're getting essentially 2 times 10 to the 11 electrons. That's a lot of electrons. So knowing the electric field, we could find how much charge, and then how much charge we can find the number of electrons that had to move to give us that charge separation.